Convido para vir ao palco o senhor HEIKO STIEBER.
Hello again. This time I will be talking about the international hydrogen scenarios that I see. I will be using similar slides, so don't get confused, but I will be talking about different things. So first thing, again, is the introduction of my company on this view of the hydrogen market, especially. Main industry and market growth, as I could hear from you, we are all awaiting this massive market growth, but the numbers are not quite clear, but it will be massive. Adding more hydrogen to the grid structure, what is our role in this whole game of hydrogen being developed worldwide? Where can we support the market? Due to the effect that in my first presentation, I was mainly talking about the problems, here I will show you some solutions that we can provide into the market. And at the end, I will show you the same reference slides, but we'll talk about different references. First, same slide, the greeting from the legal department. Taking a look at SMA again, just giving you another view onto this company. When we started in the PV market, we were an entrepreneur. We changed the market with our approach, with our engineering. And this is kind of like the core role of SMA, taking a look into this energy conversion market and then finding solutions for this market based on efficiency, lifetime, and solution providing, meaning that we can bring down the overall costs in the balance of systems of a plant. Because when we're talking about renewable energy, efficiency is one of the main important points. Because if I convert energy to DC energy electrically and then to hydrogen, I want to know per kilowatt hour how much kilograms of hydrogen am I producing. So we need lots of information to improve this approach. And maybe in 1 year, we will have different systems, more developed systems and more efficient systems, meaning we bring the price down of the hydrogen just by our approach. Power to gas. So let's take a look again. Where do we see the industry going and which are the main players? And where will we find that energy is now being transferred from one sector to another? And what are the problems here that we can see? So right now, if we take a look at the hydrogen market that we have, we use almost 50% for refining and for industry, for the whole overall. If we now move a few years further, you can see how this hydrogen market will massively grow on one hand, but also new sectors are added. And especially this point of ammonia fuel is now coming in, meaning we're transferring the fossil energy which we use for our transportation into electrical energy, at the end producing hydrogen or storing this electrical energy into a battery. But it stays the same. We're transferring a high amount of energy into a new sector. Also, if I now jump into 2023, a new point will come up, and this is this point, grid injection. The background at the end is, if I take a look at the electrical grid, all our generation is based on rotation. There's a turbine, there's a machine bringing something into rotation, producing energy. If we now take away this rotating energy by switching off diesel gensets, big turbines, generators, even nuclear power stations, the grid misses an important aspect. This is the grid inertia, meaning the power of the grid to withstand rapid power changes inside. Here I'm not talking about load activity, I'm talking about natural effects. Just let me describe the scenario which happened in Europe, which almost led to a grid failure. In France, nuclear production had to be serviced, switched off, so they had to switch off 3 big production sites for service. They haven't been served for a long time because Corona happened and nobody was in the plant for servicing. In addition, in Spain, we had a cold front moving through. Spain is not used to fossil heating. They use electrical heaters because in Spain it doesn't get so cold very often. And now you have lots of additional points inside of the European grid, which is all connected. And at the end, which kind of like brought the whole thing to tip, there was one sensor on a high voltage line that showed the wrong value. So the grid was, the operators were thinking there was a power flow going eastward, while the east grid was being overloaded and the west grid had a power lag. This led to a separation of the European grid for almost 1 hour. Why am I saying this? An electrical grid with separation has never been seen in this size. If you separate it, you also have to put it together again. And now it gets complicated because on one side, in the eastern part, you have lots of rotating machines that are not synchronized with the ones in the western side. So this resynchronization has to happen. So if inertia is missing, we will face the problem of grid instability. If we now transfer this all rotating mass into electrical storages will always be grid guided. They need the grid to follow and to inject. If the grid fails, we cannot do anything. So if we now transfer a high amount of this rotating mass into electrical systems, inertia will be missing, and we have to find a solution for it to have a stable grid again. So when we transfer energy sectors, it looks easy on the slide, but there's a big problem with it. We have to find new solutions. Again, the slide about the grid like we have right now in its structure, in its AC grid structure, where we have loads and producers connected. And here I'm only showing a renewable grid, meaning such a grid might not follow the old standards that we know. Because if I take a look at grid technology, I can easily say this is a technology which is very, very old. Transformers, lines, they are known since the 1800s. We are working with a structure and we haven't improved the structure for over 50 years. And now we want to integrate new resources, new storages, new production ways. That is almost impossible with this old structure. So what I would also foresee to the year 2050 is that this structure could be a DC bus. A DC bus is direct current and direct voltage. There's no alternating in it, meaning I have a more efficient grid now. I can connect my electrolyzer directly to this DC grid without power conversion. The power conversion will steal you around about 2% of your energy. So if we start thinking in a different manner by rethinking our grid, we can improve our efficiency, the price of hydrogen goes down, and we get more effective in these market niches that we're looking for. If we take a look on our role, and I see this very often, especially in the hydrogen market, it becomes very fancy to play in this market. Everybody wants to be a player and wants to talk with it. SMA has a different approach. We take a look at the market, find a solution, we provide the solution to the market to improve the market in first place. If we take a look at the overall growth, when we add green hydrogen in an amount of 150 gigawatt, where does the green energy come from? Right now, green energy, especially in Europe, is at the point that it has to be curtailed. But we have a massive amount of renewable energy already. If there's a lack of renewable energy in the country, the production of green hydrogen is almost impossible because you will be directly decarbonizing your grid by injecting the renewable energy here. So you have to build up your renewable energy to be able to produce green hydrogen. If I take a look how SMA is positioned in this market of this power conversion, you can see we have conversion from DC to AC up here. Here we do AC to DC again. Here we do DC to AC. So this power conversion in the future will be one of the most important points that we have to solve. And in this case, I see SMA being well positioned because we provide solar inverters, battery inverters, and hydrogen rectifiers, inverters, like you want to see it. Coming to the green hydrogen becoming economically feasible very soon. I told you right now, electrolyzer delivery time 2 years, add the rectifier, the transformer with it. So if you start a project right now, you will be looking at a time to finalization, I would say 4 to 5 years. Financial things have to be solved, all these permits have to be given, and then the technical problems have to be solved that you need the material on site. I would say that the feasibility of hydrogen will happen in the next 3 to 5 years. So if you look into this market right now seriously, I see that it's almost the point reached that we have to start right now. Otherwise, we won't get this drop in pricing because we're all waiting for the systems to grow and be installed. We don't have hydrogen yet. So this is an important point that we can bring to the table due to the effect that we have a production located in Germany where we can produce up to 12 gigawatt yearly of rectifiers, inverters, anything you can think of. And we're also expanding this production in the next years to double it again. This is our view on the market. We see this massive market growth. We have to participate in it. That's why we have to expand. What kind of solutions do we provide? As I said, we mainly see the big systems growing very fast, not the small systems. So that's why I'm focused on megawatt scale projects. This is a solution based on a 20-foot container, which is a rectifier unit, a transformer to the medium voltage connection, your switch gear, and your DC connection. Meaning you can place this block in the middle of your plant. You have the problem AC connection solved directly. You only connect the cable. For the DC connection, it's the same. You connect the cable, and then you can already start producing hydrogen. This is a 3 megawatt solution off the shelf. We have sold over 2,000 of these stations in different markets: PV, battery, hydrogen, and this worldwide. Meaning we know how to connect these stations to grids worldwide regarding regulations, regarding standards, and also regarding operation. Because coming from the European grid, which is very big, I have a very good standard world. But as soon as I leave the standard world, everything has to be discussed new, and especially with hydrogen, it's a new market. Taking a look at the overall setup, we use air cooling inside of these systems due to the effect that if we would use water cooling, we would need a resource additionally. Water cooling. Maybe at the site where we are, the water is needed to produce hydrogen, and that's why we don't want to use it for cooling. This cooling works up to 60 degrees centigrade outside temperature and can also be integrated, the system, into a region with minus 40 degrees centigrade. Wide range, and it doesn't make sense for electrolyzers, because if you have electrolysis, a chemical process at minus 40 degrees, you won't be happy with the whole process. It won't work. So we provide technical data that overstep the needs of the market right now, because we come out of a PV market where our systems are installed in remote areas and have to work. Looking at this overall design, we delivered this design in different versions, meaning we have earthquake packages. So you can mount these systems directly in earthquake-prone zones. We have standard coatings on these stations which are able to withstand very aggressive environments. Why am I noting this? We're all talking about offshore hydrogen production. You have wind farms in the middle of the sea, and now you're placing an electrical system into the middle of a salty air environment. It will suffer. And therefore, we know about this because often our PV systems are located on small islands in the middle of nowhere. And here we have found out how to manage these systems over their lifetime. If you need more power, in this case it is 6 megawatt, we provide a 40-foot station. The only difference is you will find 2 rectifiers in this station and a bigger transformer. We, in this case, use oil-filled transformer or oil-cooled transformers because, first of all, they are smaller in their package size, and a 6 megawatt skid like this one is very power intense, and that's why the transformer is oil-cooled due to efficiency and power means. But this is a complete biodegradable oil, and we also have an oil containment underneath. So for the example, if I mount such a system in the middle of a city, I don't have to await any problems because the only contaminating fluid we have inside the oil will not be spilled outside. Also, this oil has a very high flame point to ensure if the transformer is burning that it doesn't penetrate the earth. These systems have now been installed over, I would say, like 600 of these systems worldwide in battery and electrolysis projects. And here, I think it is really important to see that this is a point of standardization. I can drop this container on the ground, I can easily ship it, and I can easily install it. And this is what I see is mainly needed on the market: standardization, that everybody understands how to do it. And we can also provide data for the financial analysis. Because if I don't know the efficiency of the system, my whole financials might not work out because my losses in the whole system are higher than I calculated. And believe me, 1% of an electrolyzer in losses of 6 megawatt, and it's running 365 days per year. You can't imagine the loss of power you have, or better said, the loss of money you will face. So this is why I see SMA has an important role. We come out of the renewable world, and we know the points that are important in the overall system, not only the rectification we do. We know the points in the overall system to achieve a higher efficiency from the technical side to bring down the price. Coming to the references that I have picked out, and here I just want to point out a reference in India, which is again a fertilizer company. But these fertilizer companies, they produce their hydrogen using solar. They fill their tank, and when they produce fertilizer, they can take the energy out of the tank. We are also very active in this region in France. Here we have a company that is building up a hydrogen hub, because especially in the north of France, we find very heavy hydrogen industry. You have to consider Lyon as a big city in France, does almost 80% of the oil refining in Europe. So building up a hydrogen site right near to Lyon makes sense for the customer in the sense he has an off-taker. And this is one important point that I always have to say when I present these information. If you don't have an off-taker for the hydrogen, you shouldn't produce hydrogen, even if it's green and sexy and everything. It is right now more financial gain, because if we don't regard the financials, we need subsidization from the government. And I know that subsidization, especially for a fast-growing market, is very, very dangerous, because if the government says no, lots of money is lacking in the market, and lots of people will leave the market again. Thank you very much. I see my time already, and I'm looking forward to the discussion. Thank you.